Today our topic is related to graph data structure. There are two types of data structures. One is linear and another one is non-linear. The examples for non-linear data structures are trees and graphs, where the data is not stored in a sequential format. In a computer memory, data may be stored in a non-sequential format. Then the data structure is called a non-linear data structure. Such example is a graph. Graph generally we denote with G, V comma E. V denotes vertices, E denotes edges. So first we will consider the Cartesian product, V cross V. Suppose A, B, C are the three vertices. Cartesian product is ABC cross ABC, that is AA, AB, AC, BA, BB, BC, CA, CB, CC. That pair is denotes edge. AA, AB, AC, BA, BB, BC. Each one represents one edge. ABC individually represents vertices. The ordered pair AA, AB, AC, each one represent a edge. So subset of a relation is called a graph, or subset of a Cartesian product is called a graph, mathematically speaking. If the self loops are not there and the multiple edges are also avoided, then the graph is called a simple graph. Self loop means A to A there will be a one loop, C to C there will be one loop, B to B there will be one loop. If you avoid those self loops and multiple edges, self loops and multiple edges are avoided, then the graph is called a simple graph. Suppose here another definition. What is a subgraph? Consider GV comma E be a subgraph G dash, which is V dash comma E dash, where V dash is a subset of V and E dash is also a subset of E. That is nothing but simply graph is a combination of vertices and edges. You pick some vertices and some edges, form a new graph. Then the new graph is called a subgraph of the original graph. Here vertices are A, B, C, D. 4 vertices are there. Take any 3 or 2. There are so many edges like A, B, A, C, B, C, B, D, C, D. So different edges are there. Consider some edges. Subset of some vertices, subset of some edges. The combination is called a subgraph. Slowly we are moving into a typical terms. Please write down. It is very useful for you if you write it. Right means slowly connected graph. Suppose if you consider this graph A, B, C, D like this. Consider vertex 1, vertex 2 and consider the status also. Suppose consider vertex A here, vertex B here. Does there exist a edge between A and B or not? Yes. So that is called connected. These two vertices are connected. Suppose consider B and C. B and C. There is a edge, so it is connected. C and D. C and D. There is no edge, so these two vertices are disconnected. D and A. D and A. There is no edge between D and A, so disconnected. D and A disconnected. A and C. A and C connected. B and D. B and D disconnected. B and D are disconnected. So this is a disconnected graph, because for some vertices there is no edge between those two vertices. There is no path between. If there exists a path between every pair of vertices, then only the graph is called a connected graph. So this is a disconnected graph. I will repeat again. If there exists a path between any two vertices in the graph, then it is called a connected graph. Connected graph. Otherwise, it is called a disconnected graph. The example what I have explored now is a disconnected graph. This is a disconnected graph. Now consider. By looking into the first graph, we can easily say that it is a disconnected graph. Yes or no? This is a disconnected graph, because for the vertex E, there is no path between C to E, D to E, B to E, A to E. There is no path. So it is an example for disconnected graph. But if you consider this G dash, what is the relation between G and G dash? Can anyone reply? What is the relation between G and G dash? Anyone in the class?
G dash is subgraph of G, sir.
Yes, good. Who responded?
44, sir.
44, it is good. G dash is a subgraph of G. G dash is a subgraph of G, because here A, B, C are the vertices. Here A, B, C are the vertices. These three vertices are taken from G only. And A, B, B, C, A, C are the edges. These three edges are also taken from this G only. So G dash is definitely a subgraph of G. And moreover, whether G dash is connected or not. Tell me, G dash is connected or not?
Yes, sir.
Yes, G dash is connected, but G is not connected. So G dash is called a connected subgraph of G. Do you agree with me? G dash is a connected subgraph of G.
Yes, sir.
Yes. Come to G double dash. G double dash is also a subgraph of G. Do you agree?
Yes, sir.
Yes. G double dash is also a subgraph of G. And G double dash is connected or not?
Yes, sir. Connected, sir.
Yes. So G and G double dash are the subgraphs of G, and at the same time those two are individually connected. Yes or no?
Yes, sir.
Yeah. G, but G is not a connected graph, which is a disconnected graph. G is a disconnected graph, but G dash and G double dash are the subgraphs of G. At the same time, they are connected. Personally, they are connected. So, among these two, what is the maximal one? Maximal graph. Maximal one means which is having more number of vertices and edges. G dash or G double dash?
G double dash, sir.
G double dash. So this is called a connected component. So I would like to give a definition of a connected component like this. The maximal connected subgraph of a disconnected graph is called a connected component. Can I repeat the definition? The maximal subgraph of a disconnected graph which is connected is called a connected component. I will repeat. This first one is a disconnected graph. These two are the subgraphs of G, but these two are personally connected. Personally connected. Among these two, the maximal one is G double dash. So G double dash is called a connected component. So the maximal connected subgraph of a disconnected graph is called a connected component. So this one G double dash is called a connected component. Clear?
Yes, sir.
So how a graph can be represented in a computer memory? Graph can be represented in a computer memory in two ways. One is adjacency matrix, another one is adjacency list. Here you see A, B, C, D vertices. So A, B, C, D, A, B, C. There is a edge between A and A which is represents 1. If there is no edge between any two vertices, then corresponding value will be 0. Suppose D and A, there is no edge between D and A, direct edge between D and A. At the same time, A and D also, there is no direct edge, so that's why it is 0. A and D, it is 0. D and A is also 0. If there is no direct edge between any two vertices, then it is represented with a 0. Otherwise, it is represented with a 1. Suppose if you consider A, B, C, D like this. What are the nodes adjacent to A? A, B and C. Those are represented like this, B and C. What are the nodes adjacent to B? B, A and D. So A and D and C also. A, C, D. What are the nodes adjacent to C? C. A, B, D. A, B, D. What are the nodes adjacent to D? D. B and C. So second representation is called a adjacency list representation. First one is a adjacency graph, adjacency matrix representation. Okay. So first, what is the definition of a graph? Next is a simple graph. Next is a subgraph. Next is a connected graph. Connected graph and disconnected graph. And connected component. Connected component, I will repeat again. This first is a disconnected graph. These two are the subgraphs of G. These two are personally connected. Among these two, G double dash is a maximal one. So that's why G double dash is called a connected component. How to represent the graphs? Next is a biconnected graph. Next is a biconnected graph. A graph is said to be a biconnected. First, it should be a connected graph, like this. These two are the connected. First, it should be a connected graph. And after removal of the any node in the graph, still it should be a connected. If you are removing any node in the graph, it should be still behave like a connected. Then the graph is called a bi-connected graph. Suppose if you consider this example, can anyone say this is connected or bi-connected? Sorry, connected or disconnected?
Connected, sir.
This is connected. Whether it is bi-connected or not, we need to check. How to check? First point, it is connected. Yes, it is connected. Now, second point is, if you are removing any node in the graph, still it should behave like a connected. Then it is called a bi-connected. So you consider this example. You try to remove different vertices and see what will happen. If you remove the node A, it will be like this. It is also connected. If you remove node B, it will behave like this, connected. If you remove C, it will behave like this, connected. If you remove D, it will behave like this, connected. Remove E, it will be like this. Remove F, it will be like this. So it is a bi-connected graph. If you are removing any node, the remaining graph is still connected, then it is called a bi-connected graph. This is a graph which is connected. This graph is connected. This graph is connected. Now check by removing all the nodes one by one. If you remove A, what will be? Yes, it is connected. If you remove B, it is connected. C, connected. D, it is like this. If you remove D, it is like. If you remove E, it is this, connected. If you remove F, it is connected. Likewise, if you remove any node in the graph, the remaining graph is also a connected. Then the graph is called a bi-connected graph. So this is a example for bi-connected graph. This is an example for bi-connected graph. Now check for this example. This is bi-connected or not? First, what is the first condition for bi-connected? What is the primary condition for a bi-connected?
It should be a connected graph.
So it is a connected, right? It is a connected.
Yes, sir.
Connected in the sense no vertex is far away from the remaining group. Simply saying, suppose if you see this example, yeah, if you consider this example, there is a E, which is there is no relation between E to this graph, so this is disconnected. So here is the not the case, all are connected. Now check by removing the things. Remove A, what will happen? Remove A, and this is the case. Remove B. If you remove B, what is happening here? If you remove B, A become isolated. Remaining graph is like this. If you remove B, like this. So this is not an example for bi-connected graph, because if you are removing B, this is not becoming a connected, not a connected graph. If you remove C also, same case. If you remove D, but it is connected. If you remove E, also connected. If you remove F, then also it is not connected. So this is not a bi-connected graph. This is not a bi-connected graph. So this one is not a bi-connected graph, because if you are removing some nodes in some particular places, it is not connected. So this is not a bi-connected graph. Suppose if you consider an example, this is a yeah, if you see this example, This is not a bi-connected graph because yeah, if you consider this example, if you are removing B in this example, if you are removing B, what is happening? This is happening. So at that time, please don't confuse, at that time that B is called an articulation point or a cut vertex. Articulation point or a cut vertex. Those simple components are called bi-connected components. Suppose you are considering this graph. You are considering this graph. We are checking whether this graph is bi-connected or not. Bi-connected means first it should be connected. Yes, it is connected. We agree. It is connected. Now check whether it is bi-connected or not. How to check bi-connectedness? We need to remove one vertex at every time. Suppose if you remove vertex A, then it is good. It is connected. Suppose if you are removing vertex B, then A will be separated and C, D, E, F will be separated. So A will be separated, C, D, E, F will be separated. So if you are removing the vertex B, then it is not behaving like a connected. So this is not a bi-connected graph. But at this point, if you are removing the node B, then the graph is separated into two subgraphs, and those two are isolated, each and are isolated. A is isolated, remaining things are isolated. So those two are called bi-connected components, and the node B is called articulation point or a cut vertex. Yes, here I am giving the definition. Consider a graph which is not a bi-connected, then delete a node. Then the graph can be breaks into two or more connected components. This can be referred as a bi-connected components. The node which is deleted is called an articulation point. Right? I think this material everyone I have shared with you. Once you go through this up to bi-connected components, if you have any doubt, please ask me now at this point.
Sir, group lo the share avlet sir material.
WhatsApp lo పెట్టానమ్మా.
Avlet sir adi.
ఎందుకు అదో? Yeah, it will. I think it will share now. You check after 5 minutes. Your signal is poor. I will share with you. But anyhow, whether this concept has reached or not, please tell me. If you have any doubts, please ask me.
Sir,
Immediately.
articulation point మళ్ళీ చెప్తారా sir?
Yes. Raja?
Sir, చెప్పండి sir.
Yeah. Yes, now tell me the answer, sir. I will ask you people. Suppose I am considering this graph. I want to check this graph is bi-connected or not. How to check? Tell me.
ఫస్ట్ అది కనెక్ట్ లేదా చూస్తాం సార్.
Yes, whether it is connected or not.
Connected, sir.
Yes, first point is satisfied. What is the second criteria?
ఏదో ఒక నోడ్ రిమూవ్ చేస్తే అది తర్వాత కూడా కనెక్ట్ అయ్యిద్దా లేదా చూడాలి సార్.
చూడాలి కదా. Yes or no? So first remove A. First remove A. It will be like this. Yes or no? Here you see the graph this. Remove A. Then B, C, E, F, D. B, C, E, F, D. So it is connected. After removal of A also it is connected. Yes or no?
Yes, sir.
Yes. Suppose now remove B in this graph. In this graph,
Not connected.
sorry, in this graph, remove B. In this graph, remove B. Then A is separated and C, E, F, D is separated. Like this. A is separated. A is separated. C, E, F, D is separated. You are removed B. Yes or no? You removed B. A is separated. C, E, F, D is separated. You are
Yes,
there?
sir. Yes, sir.
So that B is called a articulation point or a cut vertex. Here two components are formed. This is one component, A is one component. These two are called the bi-connected components. These two are called the bi-connected components. That B is called a articulation point or a cut vertex. Similarly for C also, if you remove C, AB is one component, DFE is another component. So C is called articulation point here. AB is one component, this is another component. These two are the bi-connected component. But if you remove D, it is still behaving like a connected. No problem here. If you remove E, then still it is behaving like a connected. If you remove F, then two components are formed. These two are called bi-connected components and F is called a articulation point. Okay. So that's why I given a definition here. Consider a graph which is not a bi-connected. Then delete a node. Then the graph can be broken into two or more connected components. This can be referred as a bi-connected components. The node which is deleted is called a articulation point. Articulation point or a cut vertex. Tomorrow class I will explain about DFS and BFS. But for today, if you have any doubts, you please ask me. I will wait for 10 minutes, 10 more minutes.
సార్ ఇంకో కాన్సెప్ట్ కూడా చెప్పుకుందాం సార్ ఈరోజు.
Yes?
ఇంకో కాన్సెప్ట్ కూడా చెప్పుకుందాం సార్.
DFS and BFS రేపు చెప్తాను. Okay, friends, if you have any queries, please ask me, or you can call me in the during evening 7 to 8. I have given the time. Anvita,
Sir,
have you posted the 7 to 8 is the doubts clarification time? Have
yes,
you
sir.
posted? Inform it to all. Have you
Yes,
informed?
sir.
Yeah. If you have any doubts, you can ask me at the time, or you can ask me during the class, end of the class also you can ask. But please practice more. We have syllabus is very huge syllabus, and we have got a big gap. People usually tempt to feel that the class is the subject is tough, since we have got a good gap. So please practice more and more, and ask me the doubts during that time. Okay, bye for today.